Don't know the answer? Ask the Naked Scientists.
Hello and welcome to Ask the Naked Scientists with me, Dave Ansell, and our presenter this week, Tony Gillam.
Now, billions of years after it first happened, Dave has new news about the dinosaurs tonight. I'm all ears here, Dave. What's this?
That's right. It's an interesting story. Basically, you've seen lots of pictures of dinosaurs, and people keep looking at the bones and they keep finding more and more species. There's a guy in the States who's discovered that some of them might not actually be different species, because he's been looking at a great big collection of these dinosaur bones, which he's found. And you know, one of the really famous dinosaurs is Triceratops.
Oh, yeah. You used to have the model for my little girl, I think, the Triceratops.
Yeah, three big horns and this kind of skirt thing around the back of their head. And he's been looking at these, and he's found lots and lots of really young things, which they're calling Triceratops. And as they seem to grow older, their kind of horns seem to change direction. And there's another species, which everyone thought was another species, called a Torosaurus, which they thought were entirely different. It was sort of bigger than a Triceratops. It's got horns pointing different directions. And Triceratops have got this weird kind of bony skirt around the back of their head. On the Torosaurus, they've got big holes in it, so they think it must be a different species. But he's been looking at lots and lots of different dinosaurs, and it seems there's no young Torosauruses. And there's no really old Triceratops. And so he reckons that actually the Triceratops, its skull completely changes shape as it gets older. And it's, the horns change direction, and this skirt sort of gets bigger and bigger and bigger, and it starts forming holes in it. And they're actually all just one species.
That's interesting, you see, because we're talking, as I said, when we first started talking about something that's happened millions and millions of years. When's it the dinosaurs died out?
Sort of about 65 million years ago.
Yeah, a long time ago, isn't it? Yeah. And here we are discovering new facts about it. It's fascinating, really, isn't it?
When you think about it, almost all we know about dinosaurs is from their bones. And actually, if a species grows up, different sexes of the same species can look entirely different. So there could be all sorts of things which you think are different species, which are just different stages or different sexes of species we already know about.
Has there been any reaction to his discovery?
There have been various people who kind of think, interesting. A lot of people aren't quite going, definitely that's what's going on.
Yeah, because I suppose it's difficult, isn't it, to absolutely prove beyond doubt that is the case, because, dinosaurs are still pretty rare.
Yeah, this is actually quite rare that they've actually found sort of 100 or so skulls in one place, all sort of similar time. Whereas, normally a lot of dinosaur stuff, it's kind of with half a skull found in one part of the world, another half somewhere entirely the other end, and most of it's actually done with teeth.
Actually, it's kind of a follow-on question to the dinosaur bones that we were just talking to, Dave. John the Butcher, he says that South American Indians are said to be able to shrink heads. Is that a myth, or is that actually possible, do you think?
I think I looked into this a while ago. What's going on is the first thing they do is it's not a whole head. They take out all the gubbins inside. So they sort of get a head, and then they kind of take out all the bone and all the brain and things. So just got the skin on the outside. And I think it just dries out, and as the skin dries out, it shrinks and shrinks and shrinks. And you end up with this really weird, distorted model of a head. I think they might stuff it a bit so as it shrinks in interesting ways.
Yeah, actually, that's reminded me of my question, because knowing that you were on, I thought, what can I ask Dave tonight? And I'm not sure if I've asked you this one before. Why is it water expands when it freezes?
Have you ever seen a molecule of water, or a little diagram of a molecule of water? It looks like Mickey Mouse, with the oxygen, it's H2O, so two hydrogens and one oxygen. So the oxygen is like the head of Mickey Mouse, and the two hydrogens are like the two ears. Because it's kind of bent.
Yes.
And the oxygen from different molecules attracts the hydrogen from the other ones. They all sort of stick together. And then they kind of stick together, forming when they're in water, they're all moving about and kind of wriggling around and moving past one another. But as they cool down, they form things called hydrogen bonds, where the hydrogen atom sticks the oxygen atom of the other molecules. So not quite as strong as inside the molecule, but still quite strong. That forms up this great big structure. And in the structure, there's these big holes. So when it's actually formed the structure, there's bigger holes in it than when they're all rolling past each other when it's molten. So it expands and takes up more space.
Yeah, and that's why your pipes leak, isn't it, or burst when the water freezes inside them.
Why fish can survive in lakes when they freeze over, because the ice floats up to the top, and if it sank, the whole thing would solidify.
Wow.
And probably the Earth would be frozen if it wasn't for this. The whole oceans would freeze and never melt.
Actually, I've got a question about the Earth, which came in the other day from Ravindra. What would happen if the Earth tilted 90 degrees? Now, that's a fascinating question, isn't it?
It is. At the moment, the Earth is tilted over at about 23.5 degrees. Uranus is actually tipped over almost at 90 degrees. You'd have really, really serious seasons, because during our summer, the North Pole will be pointing straight at the sun, and then during our winter, it'd be pointing straight away from it.
Oh, yeah, right.
So, the North Pole would go from kind of blistering hot, equator temperatures, if not hotter, to far colder than it ever gets. It would be much hotter than the equator and much colder than the middle of Antarctica during the year. The only place which would be marginally habitable would probably be somewhere around the equator where the seasons wouldn't be so strong. You have incredible seasons. What the knock-on effects of that, I wouldn't like to think. I'd be surprised if life could have got a hold, because just from these really serious seasons would be a nightmare.
It just shows how amazing the natural world is, that it happens to be tilted at that 23 degrees to provide the seasons that we're used to, I suppose.
And actually, it's a moon which actually stabilises the Earth. If we didn't have the moon orbiting us, then the Earth's its angle would tend to tip much more than it does. Mm-hmm. And it would have made life much more difficult, certainly complex life like ours.
We don't just throw this show together. I've got a question here about the moon as well, since you mentioned it. This is from Miley, asking why there is no oxygen on the moon or any of the other planets for that matter.
The first thing is there's actually virtually no atmosphere on the moon. The reason why we have an atmosphere on the Earth is that the Earth is very heavy, it's got lots of mass, and gas, although it's very, very light, it still weighs about a kilogram cubic metre air on the surface. So all the air is kind of attracted to the Earth by gravity, and then it slowly attracts more and more until you've got an atmosphere. And it's sort of, in fact, most of it's come by outgassing from the centre of the Earth from when it was made, and possibly comets coming down, dropping lots of gases on. So you create lots of gases. It's also getting blown away. The sun produces this thing called the solar wind, which is little particles of hydrogen and helium which fly out incredibly high speeds, and they'll knock off anything which is far enough away from the Earth. It gets hit by the solar wind and knocked away. So this is part of the reason why Mars has got such a thin atmosphere. It's about 1% of the Earth's atmosphere, is because it's just been blown away by the solar wind. But bigger planets tend to have a big atmosphere, so Venus has still got a really thick atmosphere. Why have we got actually oxygen on the Earth? That's purely because of life. Before life, there was no oxygen at all. It was a bizarre, vicious, nasty waste product from the first algae, which were creating it from the sun. They might have even used it to kill other creatures to keep them out of the way, because oxygen is actually really nasty stuff. It's slowly built up, and most of life is dependent on it.
OK, Dorje's on the phone now. Hello, Dorje.
Hi.
Here's Dave for you.
My question is it true that women as a species will survive longer than men as a species? And if it is true, why? And if it's not, where did this rumour come from?
That is a good question. I think this is coming from a story which came out a few months or possibly years ago. I'm not sure quite how long ago it was. Basically, there's two main sex-determining chromosomes in humans. Chromosomes are kind of groups of DNA, so great big groups of genes in every single cell in your body. And if you've got two X's, then you're female, pretty much. And if you've got an X and a Y, then you're male. And the X chromosome is a big proper chromosome like all your other chromosomes in your genome. But the Y chromosome is kind of a bit stunted. And someone did some analysis on it, and the Y chromosome seems to be getting smaller and smaller over time. Partly because there's very little it has to do other than make a male person male. As long as it can trigger whatever switches it has to do to make a male person male, then it doesn't really have to be any bigger, and it seems to be losing functionality over time, and it's being preserved in the X chromosome. And someone did some crazy prediction that after, I don't know how many thousand years or how many million years, it would disappear to nothing, and then there'd be no more men. I'm not sure this is necessarily a very accurate prediction. I think basically if all the functionality on the Y chromosome isn't doing anything very useful, then there's no reason why it shouldn't just get lost, particularly as you only acquire one Y chromosome. It can't evolve, because if you've got any other chromosome, you would normally have two of every chromosomes, and then they kind of swap each other over as you form the eggs and the sperm.
Surely it's doing a big job. I mean, it's making men.
Yes, but that doesn't necessarily have to have all sorts of other information. Like it doesn't, for example, have to code what shape hands are and things. And all it really has to do is make one signal which tells all the other chromosomes to make a man rather than make a woman.
Trigger a man.
Yeah, so it doesn't actually have to do very much. All it has to do is do that triggering. But yeah, I think the sex determining actually changes quite fast over lots of different species actually do it in different ways. And some things, I think mole rats have crazy things with like 5 or 6 X and Y chromosomes and all sorts of strange combinations. I'm not an expert on it, and so I think if it turns out that the Y chromosome disappears, then very quickly there'd be a strong reason to evolve it back or evolve something else which does the same job.
That was really cool. Thanks.
Are you enlightened?
I am definitely enlightened.
Thanks for listening tonight. Roy's on the phone now. Hello, Roy.
Good evening to you, Jen.
Hello, how are you?
Not too bad, mate, you?
I'm feeling really good. I love this. I love it when the Naked Scientist come in because it's always fascinating stuff.
Oh, yeah.
What's your question then, Roy?
Well, about moths. They're attracted by light. Does the moon affect moths? Would they go for the moon when on a bright night, bright moonlight night?
Well, we've had a full moon, haven't we, this week? Yeah.
Yeah.
What I understand is going on with the bright lights is that moths, or certainly what I've heard, is that moths use the moon as a way of navigating in a straight line. And so if a moth wants to go in a straight line, all it has to do is keep the moon at sort of 60 degrees to the right, and then it will go northeast or so. Not northwest or so. And so as long as it keeps the moon at a certain angle, then it carries on flying with it at a certain angle, it will go in a straight line. But this works because the moon is a very, very long way away. The problem is, as soon as you come to a light on the Earth, which to a moth looks quite like the moon, if it keeps flying with the light to 60 degrees to the right, it goes in a circle because the light's much closer, and so it keeps on going in a circle. And so I think that's the big problem, that moths think your lights are the moon. They try and fly in a straight line, and they end up going in circles.
You're a clever chap. Thank you very much.
Brian Wynne came up with this question. He says, I woke up this morning thinking about this, and I wondered if Dave can enlighten or illuminate me. And he uses those words very carefully because it's a question about lasers. He says, I was sitting on a couch playing with a handheld laser pointer, a pretty powerful one at that, and I was explaining to my friend about how a laser works. The beam reflected off a plasma screen telly opposite me and bounced onto the wall behind me. The spot was composed of smaller dots, and I was unable to explain to my friend what we were seeing. Can you enlighten us on that one, Dave?
I can certainly make a stab. Okay, when you shine the laser light on the piece of glass at the front of the screen, you'll get one reflection. Mm-hmm. You might also get another reflection off the back of the piece of glass. If you looked at the thing very carefully, looked at the reflection from a piece of glass, you normally actually see two, one from each side of the piece of glass. Mm-hmm. It's also possible the back one is slightly more complicated because there'll be all sorts of structures. There might be lots of structures glued onto the back of it in a plasma screen. Mm-hmm. But even with just two reflections, especially if the back one's slightly more complicated, because laser light is very, very pure and light's a wave, if you've got more than one reflection, in some places the two waves will add together and they'll be moving together, and so they'll produce a much stronger wave, so they'll produce really bright light. In other places the two waves will cancel each other out and produce dark light. So almost whenever you shine a laser spot on anything, if you look very carefully, you'll notice that it's actually not a pure light, it's actually kind of all speckly.
Is it? I haven't noticed that.
Especially if the surface isn't quite flat, because as the surface moves in and out, in some places
refracting it differently.
Interfere constructively and destructively. So it could very possibly be that. I have to see exactly what kind of spots he was talking about. But it could be that all the pixels on his screen might not produce a second reflection as strongly as the places where there's no pixel edges, as it were, and so you might get more spots out of that.
Well, that's fascinating stuff, isn't it? Hey, yeah. So what were you doing pointing a laser at the telly screen anyway? That's what I want to know.
Be careful with those green lasers.
Yeah. They, even the small ones, like you say, can be dangerous, can't they? Right, back to the real science now. Why is the hydrogen atom larger than a helium atom? This is from Jessica.
It's a good question. You'd expect it to be the other way around because the hydrogen atom, of course, has one electron, but the helium atom's got two. This sort of thing is really quite complicated, and as ever with science, it's always more complicated than anyone ever says. You've got two electrons. They can basically take up the same space, the same volume. So having two electrons in an atom doesn't really take up any more space than one. Mm-hmm. And because a helium atom has got two protons, so it's twice as positive as a hydrogen atom, then the electrons are attracted to the nucleus twice as strongly, so they'll get pulled in harder, so they'll end up smaller than the hydrogen atom. So because there's more charge there, it pulls everything in tighter, so it makes the atom smaller.
Back to lasers, actually. Mark in Dunstable. Mark says, is laser eye surgery safe? How safe is it? I've actually had this done. So.
I mean, I guess a lot of people survive the experience. It's quite interesting what it's doing. What it's doing sounds quite scary because basically the problem is if you need to wear glasses, your eye is the wrong shape for your cornea, the front surface of your eye, which acts as a lens and converges the light to the back of your eye, which means that the lens, which actually only just makes fine adjustments to the focus, isn't strong enough for you to focus anymore, so you need to wear glasses to fix it. And so basically they blast away at the surface of your cornea to change its shape so you fix the shape, so you didn't need glasses anymore. I think if you need to do something really serious, they've actually got to kind of peel away the front surface of the
Yeah, they do
cornea,
that.
and then they blast away at the back, and they peel
Yeah.
it back.
Yeah.
I mean, it sounds completely scary. I certainly haven't seen numbers, but it seems fairly common. It seems common enough that I'd be surprised if it was particularly dangerous. But please don't sue me if it goes wrong.
You don't kind of see any stories about it going wrong, do you?
And there must be a failure rate, because
There must be,
everything, there is always a failure rate for
Yeah.
everything, because you always get some strange person who has a strange reaction to some kind of medicine. I'm sure the optician would tell you what the failure rate is if you asked him.
Yeah. And of course, they don't go into it willy-nilly. You do have to have a consultation once or twice, and they have to do tests and all sorts of things before it will even agree to go ahead. So, yeah, it's really sad. Now, I need to put my glasses on to read the next question, which I think is a great question here. This is, I hope I got the name right. Cy Emrys, is it? It says, could you have a microwave-like appliance, e.g., or i.e., one that does not itself have significant heat or cold value, yet works at a short distance to make food colder rather than warmer?
It's a fascinating one, isn't it?
Yeah, because isn't it molecules rubbing together that causes the heat in microwaves?
A microwave oven works by giving out microwaves, which are essentially a type of light, type of electromagnetic radiation, a bit like radio waves. In fact, virtually the things which your mobile phone works on. These, basically, the energy from these is absorbed by the food, move the molecules about, and that gives them energy, and the way they take in the energy is as heat, and so the thing gets hot. Making things colder is more difficult because you've got to stop them moving, and they start off moving in all sorts of random directions, so it's very, very hard to do anything to them which will make them stop moving, except by taking that energy out by putting something colder on them, so the heat can sort of diffuse out of them. In some very special circumstances, you can kind of shine lasers on things, which does actually make them cooler. But these are really bizarre circumstances. If you have some gases whereby you can make it so that when they're very, very cold, they can't absorb the laser light. If they get a little bit hotter, they can. And so any atoms which get a little bit warmer just get kicked out by the laser light.
Oh, I see.
So what's left is only the really, really cold ones. And so you can cool things using lasers, but only sort of in gases in very small circumstances by kicking out hot atoms.
Sounds like you need a serious bit of lateral thinking on that one.
So as far as I know, I've never heard of a way of doing it.
And going back to the microwave energy in heated food, when you actually eat the heated food, is there any microwave energy still in there, or is it dispersed?
Not at all. It all decays in a few nanoseconds.
Oh, I see.
So very, very quickly, certainly microseconds. And then it's basically just hot. The only odd thing about microwave food is that because the microwave doesn't actually cook entirely evenly, because in the microwave, in fact, it's the same interference effect, which is producing the spots on the laser from the laser on the wall. And you essentially have two waves, one going across the microwave from what's called the magnetron, which makes the microwaves, and then the reflection. And in some places, they add together constructively and produce a really, really hot patch. In other places, they destructively interfere, cancel each other out, and you get cold patches.
Oh, I see.
Which is why there's a turntable.
Oh, right.
So
It's all
food through the hot and cold patches.
Yeah.
But if you get some bits of your food might get extra hot because they're in a very hot patch.
Yeah.
Other bits might not be heated up very well in a cold patch. So the big difference is that some bits of the food might be very hotter than they would be.
Because I don't know whether they still do. In the early days of microwaves, they used to say once you've microwaved your food, leave it stand for a little while. Is that so that the heat sort of disperses through the item that you're cooking?
Yeah, pretty much. Because the microwaves don't actually cook from the middle. They the outside will get the hottest, and then but it goes in for about, they'll absorb energy for the top inch or inch and a half. But the very centre of a big object won't get any heat. So the only way that he can get in there is just for it to stand and wait for that heat to just slowly move through the food naturally.
It's always a shock, though, isn't it, when you tuck it into your baked beans that you just microwave to find the hot one. That's really, really hot. Actually, we've got a heat-related question in from Les in Ober. He said, is there a theoretical maximum as far as heat goes?
Certainly from a sort of classical physics point of view, and until you get to really bizarre physics, heat is basically how much energy per sort of atom or per little particle in your system. And there's no real limit to how much energy you can keep on giving things. They can just get hotter and hotter, move faster and faster and faster. And unless you get to a limit on how much energy you can give something, how fast it can go, then there's no real limit on how hot it can get. So as far as we know, we've never reached it.
OK, thank you very much for that. And let's get back to the phones now. I think Laurie's waiting there. Thanks for being patient, Laurie.
Hello, mate.
Hello. Where are you ringing from?
Walton-on-Oath.
So what's your question then, Laurie?
I was watching a program on TV, the Discovery Channel, and they had a thing on there. They was talking about this experiment called the Mars Express, which is landing a man on Mars. And they were talking about having a separate living capsule attached to the main capsule and spinning it to create artificial gravity.
Yeah.
Now, my question basically is, I can understand if you're on a planet and you spin something, you get a build-up of gravity, which is probably multiplies the amount of gravity, yeah? But if you're actually in space where there's no original gravity whatsoever, how can you make artificial gravity when there's nothing to start with?
By the spinning motion.
Yeah. It's not really artificial gravity, although it feels almost exactly like gravity. If something's going in a circle, basically things want to go in a straight line. And to make them go in a circle, you've got to apply a force to them. And so if you're a kid playing on a roundabout in a playground, you ever do that?
Yeah, I can understand because there's already gravity around you. There's something originally there.
It's not actually the gravity which is throwing you out at all. It's just because you want your body, any mass wants to keep on going in a straight line, but you're hanging on really tight to the roundabout, and the roundabout is forcing you to go in a circle.
Right, okay.
And so it's applying a force to you, a bit like the way the ground is applying a force up on your feet to stop you falling through it. And therefore, it feels exactly like gravity. It's an acceleration. And therefore it behaves like gravity, but it's not actually gravity, if that makes any sense.
Yeah, I guess it does. It's just, originally I couldn't think why, if you're taking zero gravity in space and suddenly creating it from nothing. That was just... So
in space, the natural motion is still straight ahead.
Going in straight lines unless a force pulls on you. And so, you feel the centrifugal force if you go around in circles just as you would on Earth.
Don't lose any sleep over that one, Laurie.
Okay, mate.
Good to hear from you. Thank you very much.
Cheers.
Actually, Dave, we're going to go back to eyes because we had an interesting call from Michael, who's listening in Corby tonight. He says that he's blind in one eye and he's got cataracts in the other. And he says, could he still have laser eye treatment?
I don't know.
Is that for the cataracts, I presume?
I guess for the cataracts. Yeah. I think the general way of dealing with cataracts isn't so much to blast them away with a laser. I think they tend to actually just do an operation and pull them out of the way. So this
when your lens sort of clouds over, isn't it?
Yeah, your lens sort of crystallises and forms lots of little crystals inside it, at which point it kind of goes all fuzzy, and so everything you see is all fuzzy and kind of cloudy. And the only real thing you can do is get rid of that lens. I haven't heard of treating it with lasers. It sounds slightly dodgy. But
so could you take that lens out and put an artificial one in?
They just take that. In fact, people have been doing it since about the 6th century BC.
Wow!
Apparently an Indian guy got this sort of special bent needle which is stick into the eye and then push the lens out the way, sort of into the back of the eye where it isn't in the way, and people's vision would get better since then. But apparently they only do it in extreme cases. I guess the only problem is if your other eye is blind, any surgeon or any treatment, they're going to be very suspicious.
Yeah.
And they're going to be very careful, because if they get the second eye wrong, then you've got no side left.
I did see, I think, a TV show last year about that they're working on something. I can't remember any of the details whatsoever, but all I can remember is they're working on a treatment to cure blindness. I'm not sure if it'll work in 100% of the cases, but they think they found something.
There's lots of different types of blindness. I mean, some of them you can already cure if there's just something in the way. You can get it out of the way.
Oh, right.
Yeah, it depends. There's lots of different ways.
OK, well, thanks for that question there. Now, could you explain, in layman's terms, that's my sort of language, just what is horsepower and how is it determined?
OK, horsepower is a measure of energy, of power. So it's the amount of energy something is producing every second.
Mm-hmm.
There are different types of... So you've got an engine, and one of the critical things about it is how much energy it can produce every second. Because if you want to accelerate, the faster you accelerate, the more energy you use every second. If you're going very fast, there's going to be lots of frictional losses in your car, so you've got to put more energy in every second.
Mm-hmm.
And so a horsepower, I think, was invented by James Watt. It was broadly about the amount of power that I think actually really quite a large horse could produce. So if you want a 1 horsepower steam engine, it can replace a horse, was his idea.
Oh, I see, yeah. Simple as that.
So I think it's about, the numbers, it's about 3/4 of a kilowatt.
In electrical terms.
In electrical terms.
Yeah.
And I think you can work it out with an engine. If you want to work it out with energy, you get engines which are called, you get brake horsepower, whereby you get an engine on the end of it, you put basically a brake, and then you run the engine at a certain speed and you work out the maximum force you can apply to this brake, and from that you can work out how much energy it's producing.
Wow. And why do cars... I think I heard somewhere once that cars lose horsepower with age. Is that true?
It wouldn't surprise me at all. I mean, they're going to, as things wear, that it's going to get
because things are finely tuned, aren't they?
Things are all finely tuned.
Yeah.
Things wear, everything isn't quite injected at the right time in the right place, and gases will leak, and all sorts of bad things happen.
All right, one more quick one from the other day. I read this, and I thought it was two separate questions here. The universe is expanding. Why then is the Milky Way on a collision course with the Andromeda Galaxy? Isn't that two separate issues?
I think basically he's saying, okay, if the universe is expanding, surely everything should be getting further apart all of the time.
Oh, I see, yeah.
Rather than... but
increasing the chance of a collision, yeah?
Yeah. Well, surely there shouldn't be any collisions because everything's getting further and further apart. How can anything be heading towards each other? On a really big scale, as far as we can tell, the universe is expanding. So if you look billions of light years away, everything is going away from us. But the closer you get, although on average everything is going further away, if you get quite close, in fact there's a thing called the local group of galaxies which are all kind of orbiting around one another, then they're not actually getting further apart. It's just this group is getting further away from other groups. Our local group of galaxies are kind of gravitationally bound. They're orbiting around each other. They're not flying apart. But as soon as you get further out than that, then everything does seem to be flying away from us. That's it for this week, but fellow Naked Scientist Chris Smith will be back next week for more Ask the Naked Scientists. But don't forget, you can also catch up with us with the other Naked Scientist podcasts, which you can find online at thenakedscientist.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.